analysis of the pre-stressed concrete sections under the working load are based on a series of assumptions. First, the plank sections are assumed to remain plain under deformations, be it under compressions or under bending deformations. With that, the same set of section property can be used throughout the member. Next, the stress-strain relationships are considered as linear. Their relationship can be predicted based on the modulus of elasticity. It is also assumed that the member is bending in one direction, which is the principal axis. With that, we can simply assume that the cross-section regions above and below the centroid axis in the form of compressions or tension. As for the pre-stressing force, the value is considered as the remaining after all the losses have occurred, as the calculations of the losses is rather complex. The exact amount of the losses will be checked in detail at the later stage of the design. It is also assumed that the changes in the tendon stress due to the applied load on the member have negligible effect on the behavior of the member. The applied load on the member can cause deformations to the member. This may, to some degree, affect the stresses in the tendon. To quantify that, tedious calculation steps is required to determine so. However, the changes to the tendon stress is relatively small. In this case, we assume that the effect is negligible. And lastly, the section properties are generally based on the gross concrete sections, as the sections can constitute of concrete and other material such as tendons, steel or ducting. Again, it is too complex to take into account every single one of them, as the concrete constitutes a large portion of the section and the response of the member is significantly affected by the concrete. We may simply assume the section property are based on the gross concrete sections.